Sadly, they weren't. Come on. Yield. I can explain the concept of theoretical yield. I can derive a theoretical yield under specified conditions, and I can calculate percent yield for a reaction. Lots of vocab kind of coming at you for this one. So theoretical yield is the amount of product that may be produced by a reaction under specified conditions. The key word here is it's calculated. Calculated means you're doing a stoichiometric calculation. So it is calculated, okay, per an equation. So this is in a perfect world, how much we should make. So perfect world is the way I call this one, right? Perfect world. And this is always our calculated amount. Then we have what is known as our actual yield. This is how much we actually get, okay? How much is actually obtained or created. So if you were doing a lab, this is the actual number that you make in the lab as compared to the number that the lab calculates that you should make, or that you calculated you should have made based off of the amount of reactants you used. Percent yield is going to be the extent to which a reaction's theoretical yield is achieved, or how close were we, basically. So how close were we is kind of what this is answering. So how close were we to getting what a perfect world predicted? The equation, percent yield, we have actual yield over theoretical yield times 100%. Okay. Very important to note. In order to calculate percent yield, the theoretical yield and the actual yield have to be the same units. Okay. So for example, we can't have one that's in molecules and one that's in grams, or we can't have one that's in liters and one that's in grams. They have to be exactly the same units. That's going to give us the correct percent yield. So we want them to be in the correct or the same units. Let's look at this in terms of food, because we all love food and we all know how to think in terms of food. So with cookies take 2 cups of flour, 1 cup of chocolate, 1 cup of butter, 1 cup of sugar, and that gives you 24 chocolate chip cookies. How many cookies could you make with 3 cups of flour? So in your head, looking at that equation, how many cookies could you make with 3 cups of flour? So if we just focus on 3 cups of flour, we've got 1 extra cup of flour. We've 1.5 our flour. So 1.5 times 24 would give us 36 cookies, okay? So we're just going to look at the 3 cups of flour for this one because I'm not teaching you guys what's known as limiting reagents. This year, just due to time, I had to throw that one out. So not teaching you limiting reagents. You'll be happy because they're hard. So in a perfect world, we can make 36 cookies. In a perfect world, okay? Do you think if I gave you those ingredients and I said, all right, I expect to see 36 cookies, are you going to be able to make 36 of the same exact cookies that easily? Probably not, right? So let's say we make 34 cookies. So I want to know what percentage of cookies did you make versus how many you could have made. So we're going to take our 34, which is our actual yield. This is our actual. And we're going to put it over our theoretical yield, which we said was 36. And we're going to multiply that times 100%. And when we do that, we get an answer of 94% yield. So we made 94% of what we were expected to make in terms of cookies. That's pretty good though, right? It's not perfect, but that's pretty good if you could make 94% of what you were expected to make. So the next question I have for you is, what are some reasons why we made 34 instead of 36? So what could be some reasons for that? We made them too big. All right, what else? Okay, we lost some ingredients. Like spill or something? What else? Bad cook. Maybe you burnt some. What else? What do we all do when we make cookies? Yeah, we ate some cookie dough. Right, so those are all some reasons as to why maybe we didn't make the full 36. A lot of these reasons also ring true in chemistry. Make this bigger. Except for eating. We don't eat chemicals, okay? But sometimes we fill things up too little, or we fill them up too much. Sometimes we have spills. A lot of times we have spills. Sometimes we burn some off if we're heating it, and other times it gets like it's stuck in the jar. Like not all of it can get pulled out for the full reaction. So these are some examples of why our percent yield was not at 100%. So in terms of food, percent yield is pretty easy. Hopefully, it's not too bad in terms of chemistry. So we are going to look at an example problem. So this says upon reaction of 1.274 grams of copper sulfate with excess zinc metal, 0.392 grams of copper metal is obtained according to the equation. So we have our given, okay? Our given is told to us, it's a reactant in this one, and it's 1.274 grams of copper sulfate. It actually also tells us our actual yield. It says this much was obtained, okay? So that is actually meaning that that's our actual yield. That's our actual yield. 0.392 because it says was obtained. Obtained means that's how much was collected. We need to figure out the theoretical yield and then calculate percent yield. So the first thing that we need to do is we need to figure out our theoretical yield. So step one, we're going to do our theoretical yield. Then step two, we're going to do percent yield. Theoretical yield is easy. It's just stoichiometry. So we have our given. Our want is going to be grams of copper metal because that is the unit that our actual yield is in. Does that make sense? That I'm going to search for grams. Does that make sense? Because my actual yield has it in grams. So we're going to do some stoichiometry. So we're going to do step one first. We're going to start with 1.274 grams of copper sulfate. I need to figure out the molar mass of copper sulfate. So we have copper, we have sulfur, and we have 4 oxygen. Copper has a molar mass of 63.55. Sulfur has a molar mass of 32.06. So we're going to add these together. And that gives us 159.61 grams per mole. So, because we're starting with grams of copper, we need to divide by the molar mass, which is 159.61 grams per mole. When I'm doing stoichiometry, what always goes in my middle section for my train tracks? Yeah, my coefficient or my mole ratio. So I want copper. What's in front of copper? 1. So we're just going to write 1 Cu. I was given copper sulfate. What's in front of copper sulfate? 1. So we have 1 CuSO4. Lastly, I'm trying to solve for grams of copper metal. This is what I want. Grams of copper metal. So what do I need to put in my upper right-hand corner of my right train track? The molar mass of copper, which we have up here, 63.55 grams per mole. So when we figure all of this out, where we multiply it out, that's going to give us what's known as our theoretical yield. So we're going to take 1.274 and multiply that times 63.55, and we're going to divide it by 159.61. Our theoretical yield or our calculated amount gives us 0.51 grams of copper. That's how much we should have made in a perfect world. Is the question asking for our theoretical yield, though? No, it wants to know percent yield. So the second thing we're going to do is calculate our percent yield. Percent yield is very easy. We are going to take our actual yield, which is 0.392 grams of copper, 0.392. We're going to divide that by our theoretical yield, which is 0.51, and we're going to multiply that times 100%. And that gives us 76.86. So we came close by 76.86%, or we were that close to what we should have done in a perfect world. Okay. So in a perfect world, we should have had 0.51, but unfortunately in our world, because it's not perfect, we only had 0.392. So we were off. In a lab, like if you were to take like a college chemistry lab, they would make you explain why it's not near 100%. Maybe you spilled some, maybe some was stuck to the inside of your container. Maybe your scale wasn't balanced. Maybe you had a heavy hand and you poured too much in. So things like that, human error can explain that, okay? Does that make sense? Okay. We're going to do one more practice problem. We're going to kind of chunk it up. I'm going to just kind of zoom out for that. So our practice problem. What is the percent yield of a reaction that produces 12.5 grams of Freon from 32.9 grams of ClC4? All right, what is my actual yield in this question? Yeah, see the word produces? The word produces or the word obtained are going to give you a hint as to what our actual yield is going to be. So produces that many grams of Freon. That is our actual yield. Okay? So this is our actual. What is our given? $32.9 grams of that is my given. And my want is going to be grams of Freon. Okay, so grams of that. That is my want. So what I want you guys to do is I want you to first solve for theoretical yield. Okay? So first I want you guys to solve for theoretical yield. Once we've checked that, then I'm going to give you guys time to do percent yield. Okay? So first I want you guys to solve for theoretical yield, and then we'll check that together. So go ahead and solve for your theoretical yield. Work on this theoretical yield. So our starting point is 32.9 grams of CCl4. So 32.9 grams of CCl4. We need to divide by the molar mass of CCl4, which I calculated to be 153.81 grams per mole. The middle, you should do your mole ratio. So we want Freon. Freon is CF2Cl2. We started with CCl4. So the mole ratio is 1:1. Last, we want grams of Freon. So we need to multiply times the molar mass of Freon, which is 120.91 from what I calculated. Does that look like your guys' setup? Yes, no, yeah, okay. So in our calculator, we would have 32.9 times 120.91. And we're going to divide that number by 153.81. And that should give us 25.86. So what we got? So our theoretical yield should have been 25.86 grams of Freon. Okay. Now that you have your theoretical yield, I want you guys to try to calculate your percent yield. So this is your theoretical, this is your actual. So take a second to calculate your your percent yield. When calculating our percent yield, we take our actual, which is 12.5. We divide it by our theoretical, which is 25.86. We multiply that times 100%. That ends up giving us 48.3%. Is that a good percent yield? No. We want percent yield to be high or close to 100%. So that is not a very good percent yield. Something definitely went wrong in that lab. So tomorrow is going to be a work day for you guys, and it's going to be working on a worksheet practicing these percent yield calculations, okay? We will be checking that most likely together or through a video on Wednesday. Does that sound fair? Yeah? All right. Those of you who are on the call, as long as you don't have any questions, you guys